Hello everyone, so today we're going to go through part 6 of this chapter, which is about rationalizing the denominator. So if a fraction has a third in the denominator, for example, square root of 3, square root of 5, and so on, it is sometimes useful to rearrange it so that the denominator is no longer a third, but instead a rational number. It works in our favor when it comes to certain questions. That's why it's important to know how to do it. Okay, before we get started, let you know two ways on how to do this kind of um um technique, I would say. So 1 over a, if we have a set that looks like this, what you do is you multiply it by itself in the numerator and the denominator, and you write your original one, okay? And basically what you've done here is you multiplied by 1, as you can see. So basically you've done nothing, okay? But it will help you rationalize the denominator. But in the case you have, for example, in here, in the case where you have like a something added to it, okay? So what you do instead, you multiply by the a minus square root of b over a minus square root of b. So it's the same thing as saying 1, and you write your original expression, and you simplify by manipulating. And also, when you have a minus square root of b equal, so instead of multiplying by the difference, you multiply by the addition, okay? So you do the opposite of what we've done earlier, and then you write the original expression as it is, okay? So can you see what I'm trying um to to mention here? But yeah, so we're gonna be using these in the example 14. So 1 over root of 3, so I'm gonna be using this one over here, and I'm gonna multiply both top and bottom by square root of 3, and then I'm gonna write my original expression. And I've done nothing basically here because it's 1, it simplifies to 1, but it's going to help us get rid of the third in the denominator. So it becomes 3 there, and this one simplifies to square root of 3. So in this case, which one I'm going to use? I'm going to use the second one. A minus, in our case, a is 3 minus square root of 2 over 3 minus square root of 2 times 1 over 3 plus square root of 2. Okay, so for those you have noticed, like there's a way to work out or simplify the denominator without going through so much work. So I would like to remind you of this identity, which says a minus b times a plus b equal to a square minus b square. Okay, so this is what we call difference of squares. It's very useful, especially here. You don't have to go through so many steps and add in whatever. So as you can see, let's identify, it does match the identity. So let's identify which is A and which is B. In this case, A um, is 3 and B is square root of 2. So I'm going to write the numerator as it is. And the denominator, I'm going to use this identity. So it's 3 square minus, as in the identity, then our B square is square root of 2. So it's 2 to the square. Okay. So now I'm gonna simplify. So 3 minus square root of 2 over 9 minus 2. Okay, that is 3 minus square root of 2 over 7. See, it's easy. There is another way to do it, like you can just expand as normal, but this is kind of like a shortcut. You must be knowing this for your A levels because you won't be having so much time in your exam um to be doing like all the expansion, addition, whatever. So let's move on. So for this one, um, you can see that we have the third appears in the bottom. So it appears in a different way. So again, we're not concerned with the numerator because it's about rationalizing denominators. So let's just ignore this bit here. and we'll write it as it is. Okay. And over 5 minus. So by what I'm gonna multiply, because I'm focused on this part, so I'm gonna multiply by this over here. So I'm gonna add this square root of 5 to 2, and I'm gonna multiply top and bottom by it. And this, trust me, this has nothing to do with this, okay? It's just because we're trying to rationalize the denominator. Okay, so again, I said we can use this. This is very useful instead of like doing the whole the whole um expansion. So in this case, my 5 is square root of 5 is a, and b is square root of 2. Okay, so you can see this is matching it exactly. So square root of 5 to the square minus square root of 2 to the square. And for the top part, you can expand it. Okay, so it's square root of 5 times square root of 5, so it's square root of 5 squared, square root of 5 times square root of 2, plus square root of 5 times square root of 2, plus, let me expand this, then I'll move on to this one, plus square root of 2 times square root of 5, plus square root of 2 squared. Okay, so the top part, it becomes 5 plus 2 square to root of 10. You know what, I'll write it here. So it becomes 5 plus, let's say, square root of 10 plus square root of 10. Let's not skip any steps. And then over 5 minus 2, okay? Then I'll divide by 3. So you can see we successfully got rid of the surds in the new denominator. So now all that is left is to simplify. 5 plus 2 is 7. And there's 2 of those, 2 square root of 10. Also, I would like to note another identity that is good to know when it comes to expanding. So in this case, this is equivalent as saying 5 plus square root of 5 plus square root of 2 squared. And this is what we can do is like, we can apply one of those rules. Instead of going through all the trouble, we can simply do this directly without really thinking. So you can see a plus b to the power of 2 is equal to a squared plus 2ab plus b squared. So this is what I would apply normally if I'm working on a question. So this is easy. You just identify which is a and b, and you compute it directly instead of just like doing the normal way of expansion. Is more effective, I would say. Let's move on to the next one. So this one, what a lot of you will do is multiply it top and bottom by this over this, but this is wrong, okay? Because it's just extra steps, and you're going to be making it too difficult to deal with later on. So here what you can do is you can simplify this one, because if you expand this one, you will simplify it, okay? And you will obtain a certain expression which you can apply these rules onto, okay? So yeah, now it's a good opportunity to use this one. So my a here is 1, and because in the identity is a plus, I mean in the case it's a minus, you simply have a squared minus 2ab plus b squared. So my a is 1, so it's 1 squared minus 2 times 1, because my b is a square root of 3, so times square root of 3 plus square root of 3 to the square. So it's easy, like it makes expansion like quite an easy thing to do. And 1 remains here. So here I'm just expanding, I'm not doing anything. So I'm simplifying right now. So 1 minus 2 square root of 3 plus 3, which is equal to 1 over 4 minus 2 square root of 3. Okay, so now I can apply the knowledge I've learned so far. So we'll multiply top and bottom by 4 plus 2 square root of 3. Okay, so we can get rid of any of those thirds and rationalize eventually the denominator. So again, I said when you multiply by this is equivalent to multiplying by 1. You've done nothing, no harm. And now I'll apply this formally over here, okay, where A is 4 and B is 2 to the power of 3. So it's 4 squared minus 2 to the power of 3. Again, this one only works when we have something of this form. So when you see that, just go for it, okay? And then you have 4 plus 2. Let's simplify over here, just in case we might not have run out of space later on. 4 to the power of 2 is 16. And this is 2 squared. So it's 4 times 3. So minus 12. Am I right? I think so. So moving on, we're going to have 16 minus 12 is 4 on the denominator. And this one is 4 plus 2 square root of 3. And then simplifying, so 4 over 4 is do we have to simplify? You can simplify, like you can split them or keep them the same, but I'm gonna do both of them. So here in the case you simplify by 2, okay, so it says you divide both bottom and denominator and numerator by 2, it becomes 2 plus square root of 3. And if you separate the fractions, actually it becomes 1 plus square root of 3 over 2. So now let's put these into practice in one of the exercises from the exercise set. We'll only do question 4 for today. So we have 3 minus 2 times square root of 5 over square root of 5 minus 1, which we've got to simplify. So again, we're trying to rationalize the denominator, so we don't care about the numerator. So we only focus on the bottom part. So I'm going to write my expression as it is, and let's figure out which we're going to multiply with to get rid of the surd over there. So we're going to multiply by 5 plus 1 over 5 plus 1. I'm going to put everything in between bracket, okay? And in the denominator, we're going to use the law over here, which says is the difference of square, and in this case my a is square root of 5 and my whole b is 1. And for the top part we're just gonna simply expand. So 3 times square root of 5 plus 3, then minus 2 square root of 5 times square root of 5 minus 2 square root of 5 times 1. So it remains as it is. Then we have to simplify. So 3 square root of 5 minus 2 square root of 5. So we can add those two together because they share the same term. And then plus 3 minus 2 times 5. And the 5 comes from the square root of 5 being multiplied by itself twice. So 5 minus 1 for our denominator. Okay, so we've got 4, and then 3 minus 2 is 1, so square root of 5. 3 minus 10 plus 3 minus 10. So minus 7 plus square root of 5 over 4. Why it doesn't, not a straight line. And then we can keep it as like this, or we can split the fraction and we get I think it's better to split the fraction because it said to write it in that form over there. So minus 7 over 4 plus square root of 5 over 4. So in this case, if we were to identify P and Q, so P is going to be minus 7 over 4 and Q is going to be 1 over 4. And this marks the end of our session. I hope you all enjoyed it, and I shall see you in the next one. Bye!